We'll now discuss logic programming languages. Functional programming gets away from explicitly instructing the computer about the details of each step to be performed. Instead, it just specifies the various transformations of the data and then allows combinations of transformations to be performed. With logic programming, we also don't have to specify exactly how a task is to be done. So we go a step forward and just don't have to worry about saying what needs to be actually done. So in logic programming, various facts are just asserted to be true. And on the basis of these facts, a logic program can infer or deduce other facts. So whenever we have a query or a question, whenever we have this posed to the program, it would begin with the storehouse of the facts. So it'll look up all the facts that it knows is given as true, and then it's going to attempt to apply logical deductions in as efficient a manner as possible to answer the query. So the whole point here is that we have these facts that are supposed to be true. Well, not just supposed to be, they are given to be true. And using these facts, if we're given some question, the program can use logical deduction to determine what is actually true and what's false. Logic programming is sometimes called declarative languages because their programs, instead of issuing step-by-step commands, will make declarations or assertions about the various facts that are true. Now, a logic program relates to a domain of interest in which the declarations make sense. So like in medicine or in literature or even chemistry, just as some examples. And the queries are related to that domain. In fact, logic program has been used to write what are called expert systems. So in an expert system about a particular domain, we would have this human expert in that domain that would contribute facts based on his or her knowledge and experience in that particular domain. We would then have a logic program use these facts as its declarations, and then it can make inferences and guesses that are close to those that the human expert would make. So instead of having the human actually make these decisions based on the facts, we would actually have these programs look at the information that's been given to it by some expert, and then it would come up with an educated answer to a particular question. This actually has a lot of applications in artificial intelligence, where we try to have computers act as close to humans as possible in terms of the thinking process and the decision-making process. So here, we're giving the computer facts about a particular subject area, and then the program can make decisions based on those facts. The best known logic programming language is Prolog, and this was developed in France at the University of Marseille in 1972 by a group headed by A. Kolmarauer. Now, Prolog actually stands for Programming in Logic. So as you can see, they got the pro in programming and then the log from logic. So see what they did there? Prolog. Anyway, this language basically consists of two components, facts and rules. A fact expresses a property about a single object or a relationship among several objects. For example, let's say we want to write a Prolog program in the domain of American history. So we're interested in which U.S. presidents were in office when certain events happened, and we're also interested in the order of those presidents' terms in office. So let's take a look at a short list of facts or declarations. So we would have President with Lincoln and Gettysburg Address in parentheses. We would have President Lincoln Civil War in parentheses. President FDR World War II. And then before Jefferson Lincoln. And then before Lincoln FDR. So what is this saying? Well, President here declares which president was in office during a specific event. So we can see here that Lincoln was the president during the Gettysburg Address in the Civil War. And we also see that FDR was the president during World War II. And then this before function declares which president was before another. So we can see here from the two before statements, Jefferson was president before Lincoln, and Lincoln was president before FDR. The list of facts constitutes a Prolog program. So we interact with the program by posting or asking queries. So all we're really doing here is just we're asking questions about whether or not the declaration is in the program. And these responses are always going to be either yes or no. We're just pretty much saying, is this declaration in your program? Yes or no? So for example, whenever we do a query, we would have a question mark, a dash, and then the declaration. So question mark dash President Lincoln Civil War is asking, was Lincoln the president during the Civil War? Or at least it's just checking, is this fact in the program? Is this declaration in the program? And this will return yes, because it is in the database. It is in our program. Now, if we do something like ask if Lincoln was before Jefferson, this is going to return no. Now, I want to make it very clear. When we say no, it just simply means that the declaration is not in the database. I mean, sure enough, Lincoln was not president before Jefferson. We know that that's not true. But if we were to put this declaration in the program, then this would say yes. So what these queries are doing are just simply asking or just checking, is this declaration in the program, yes or no? Now, in our earlier example, we know that Jefferson came before Lincoln, and we know that Lincoln came before FDR. So you would think, well, that means Jefferson came before FDR, right? But if we tried the query before Jefferson FDR, this is going to return no, because once again, that specific declaration isn't in the program. When we're doing a query, we're just checking, is that fact in the program? And since before Jefferson FDR is not in there, this is going to return no. Now you might be thinking, well, why don't we just add another before statement and just say before Jefferson FDR? Well, we can do that, but that just doesn't seem necessary. We shouldn't need to do that. So instead, we're going to use what's called the precedes statement. And this is some additional information where we can actually imply some more information based on what who comes before what. So let me just give you a couple of examples just to illustrate this. So when we say before Jefferson Lincoln, this implies that Jefferson precedes Lincoln. So it's basically the same thing that comes before Lincoln. Now, if we also say before Jefferson Lincoln and precedes Lincoln FDR, this is going to imply that Jefferson precedes FDR. The reason why this is important is because we can use rules to help us with handling the precede statement. So a rule is simply a declaration of the form if A, then B. Remember, we said that we have facts, which are just statements that are clearly true, and now we have these rules that say if something is true, then this is also true. So here, if A is true, or if A is a fact, then B is also true, or B is a fact. And the way we would handle the notation for this is we would have B, and then a colon and a dash, and then A. So let me give you a couple of examples of how we would do this using precedes. So we can say something like precedes XY, colon dash before XY, which means if X is before Y, then that implies that X precedes Y. And then we could also say precedes XY, colon dash before XZ, comma precedes ZY, which this means if X comes before Z and Z precedes Y, then X precedes Y. These are pretty much the exact same examples we just talked about with the president ordering. So here, X and Y are simply, and Z are just simply variables. So I mean, we can use variables in queries and rules as well. So if we include these in our rules, now if we do the query checking if Jefferson comes before FDR, we wouldn't check if Jefferson comes before FDR, but we would check if Jefferson precedes FDR. And what that's going to do is it's going to check these different precedes rules, and we'll see that we would have something like Jefferson comes before Lincoln and Lincoln precedes FDR. So that means Jefferson precedes FDR would be true, so this result would be yes. In our example, it was easy to check that the responses to our queries were correct, and it wasn't difficult to do any of the necessary comparisons with the program declarations just to see how Prolog was able to arrive at its responses. The interesting to note, though, that with this particular program, it consisted solely of just declaratives, just facts and rules. There were no instructions about what steps to take in order to produce the answers. The program just simply provided the raw material, and in the logic programming paradigm, this raw material was inspected more or less out of our sight and without any detailed instructions to deduce the answers to the query. So what the programmer does here is it builds a knowledge base of facts and rules about a certain domain of interest. and this knowledge base is the program. So interaction with the program takes place by posting queries. Now, sometimes these queries are rather complex, but they're posted to what we call an inference engine. Sometimes this is also called a query interpreter. The inference engine is a piece of software that is supplied as part of the language itself. So it is part of Prolog. It's usually part of the compiler or the interpreter and not something that the programmer has to write. So this inference engine can access the knowledge base, and it contains its own rules of deductive reasoning based on symbolic logic. So just to give an example, Prolog would support the deductive reasoning known as modus ponens, which simply means that if we know the rule if A then B, then we know that and we know that A is true, then we also know that B must also be true. So if we know this rule and we know that A is true, then B must also be true.